Hello everyone. In this example, we are going to make phase diagram for AZ31 alloy in which we are going to add strontium, that is SR. To make the phase diagram, click on the phase diagram module and let's wait for the window to open. It will ask if you want to load the last system or not. Since we are going to do a fresh calculation, so we are just going to say no. Similarly here we are going to say no again, and now we need to select the database. Since our alloy is AZ31, so we are going to select FTLite and FactPS and press OK. Now we have a particular situation here. Our components are AZ31 alloy and SR. So let's just enter SR first. Now the AZ31 alloy is normally given in weight %. So our alloy is magnesium 97, aluminum 3 and zinc 1. But in FactSage, all the input is in molar formula. Thus, in order to add AZ31, we have to do conversion of the composition into mole fractions first, then add this molar formula as input. Now, to convert this mole fraction in mass % into mole fraction, we get 0.96897. The aluminum is changed to 0.027277 and zinc is going to 0.0037517. Now press next. Okay. Here we are going to select all the phases which we want to see in our phase diagram. Since we are going to make the first phase diagram, so we are going to select all the solutions. Similarly, we are going to select all the solids. And now we need to specify what type of phase diagram we want to make. To do that, go to the variable section and double click on any of these sections. So you can double click here, 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 or here. Doesn't matter. Let's just double click here. So it will open a different window where you can select how you want your phase diagram. So I want a normal phase diagram. So I'm just going to press next. So temperature will be on the y-axis. So I'm going to keep the temperature on the y-axis. You can make the temperature constant also and just specify the temperature, but we are going to take it as y-axis from 0 degrees Celsius to 700 degrees Celsius. Our pressure will be constant at 1 atmosphere. And now we are going to change our strontium value. This 1 here does not refer to the actual amount of your component. This one is just yes or no. 0 means no, 1 means yes. So what we want is we want the change of the SR in our phase diagram. So we don't want our AZ31 to change. So we put 0 here to say that do not change this, but change SR on the x-axis. That's why we put 1 here. This does not represent the actual amount. The actual amount we have to represent here. So here we are going to start with 0 and go till 0.05. So let's just press OK. And let's click calculate. And let's wait for the result. So it will take around 5 to 6 minutes to calculate every result, compile result, and draw the phase diagram. After the calculation is done, we are presented with our phase diagram. So here you can select the width and height of your diagram. We are just going to select OK for the default value. Yep, OK. Now to label the diagram, to see which part is which phase, you go to this part where you have different modes, where the one of the mode is the stable phase label mode. So while you are in this mode, you can just simply select, left click on any part of the diagram, and it will just simply label what phases are present there. So here it was liquid, here we have SCPA3 and liquid, and similarly you will have multiple phases. You can either label all you want, or you can just label the area of the interest. So that's how you make phase diagram for any alloy. Thank you for listening.